Diamonds are, without a doubt, the most coveted gemstone in the world. And as rare as it is, it can be found in several regions of the planet. But would you like to know if your area is one of them? To keep it simple, there's a very good chance you live relatively close to one of these regions. And as generic as that may sound, it's important to understand that within these areas, there are specific spots where your chances of finding diamonds are much higher. That's exactly why, in this video, you're going to learn how to find diamonds in creeks, and you'll quickly understand why we chose creeks. They're one of the best places to find gemstones like rubies, sapphires, and diamonds without needing expensive gear, heavy machinery, or advanced mining techniques. In other words, these are accessible places where you can search for gemstones hidden in the gravel that has already been sorted over thousands of years by the force of running water. These streams that cut through forests, farms, trails, and sometimes even suburban areas can quietly move and concentrate heavy minerals right in front of everyone, without anybody noticing. In many locations, the best clues for diamonds are literally sitting under just a few inches of water. To give you a clear idea, the stone on your screen right now is a rough diamond. Notice how different it looks compared to the cut gems you see in jewelry stores. That's exactly why so many people end up ignoring diamonds in nature. For most beginners, these darker little stones look like nothing more than shiny gravel. And this is where things really change. Once you understand what you're actually looking at, your whole perspective shifts. Your life can change, not because you're guaranteed to find something valuable, but because every creek becomes a new opportunity to get outside and hunt for gemstones with a trained eye. But the truth is, even with all of this, a lot of people still aren't sure how to actually find and recognize a rough diamond in the wild. So in this video, we're going to break it down step by step. Which regions are most likely to host diamonds? What the main diamond indicators are in a given area? How to identify a rough stone in your hand? And how much a diamond found in a creek can realistically be worth, so you don't end up throwing away a valuable stone, thinking it was just another common rock. So the first thing you need to understand is that before you start scooping up gravel from a creek, you should follow two key steps. First, learn how a creek concentrates heavy material, and second, learn which minerals tell you that you're in a place with real diamond potential. Without that, you can spend the whole day working hard in the wrong spot and go home with nothing more than a few pretty but common stones. Let's start with the behavior of the water. In a straight section of a creek, the current is stronger in the middle and weaker near the banks. When the creek curves, the water speeds up along the outside of the bend and slows down along the inside. Lighter materials like fine sand and silt tend to stay in the faster part of the flow and keep traveling downstream. Heavier grains and pebbles start to drop out of the current where the water loses energy. That's why the inside of bends, especially where you see coarser, darker gravel, are classic places to check. Another key feature is bedrock. Whenever the bottom of the creek is solid rock instead of loose sand or mud, any crack, hole, or step in that rock can act like a trap. During floods or heavy rain, the water gains a lot of energy and carries everything it can: wood, mud, rocks, and minerals. As that energy drops, the heaviest pieces fall into those cracks and pockets and stay there. Over years and years, a small depression in bedrock can accumulate garnets, metallic minerals, and if the geology upstream is right, tiny diamonds. If you see exposed bedrock in a shallow creek, especially with visible cracks filled with dark gravel, that deserves your attention. Now let's talk about indicator minerals, because they're the language the creek uses to tell you what's going on upstream. One of the most important is garnet. In many diamond-related environments, you'll find small garnet grains in the creek gravel. To the naked eye, they usually look like tiny, dark glass beads, often red, wine-colored, or reddish-brown, sometimes almost purple. They're noticeably heavy for their size, and once cleaned, they show a bright, glassy luster. Many of them look slightly rounded because they've been tumbled by water for a long time. Seeing garnets in a creek doesn't guarantee diamonds, but it tells you that the system is carrying material from deeper or more metamorphosed rocks, which is exactly the kind of environment where diamonds can form. Alongside garnets, pay attention to the dark, heavy sand that often stays in the bottom of your pan or sieve when everything else is washed away. That black sand is typically a mix of different heavy minerals. Among those, two are especially interesting for diamond hunters: ilmenite and chromite. Ilmenite is usually black or very dark gray, with a subtle metallic sheen, almost like dull steel. It's quite heavy and may show small, shiny faces when you turn it under the light. Chromite is also black, but tends to be even denser and has a more rough, lumpy appearance, sometimes looking like tiny pieces of lead. Both ilmenite and chromite are associated with deep, ultramafic rocks and some volcanic systems related to diamonds. Finding them together with garnets and creek gravel is a very good sign that you're dealing with material coming from the right type of rocks upstream. In some areas, you may also find unusual rock fragments that don't match the more common local stones. They might be greenish or dark gray rocks with small black spots, or crumbly, altered pieces that look different from regular river cobbles. These can be fragments of ultramafic rocks or even strongly weathered kimberlite or lumroite. You don't need to memorize all these names, but you should train your eyes to notice when the creek's gravel suddenly changes character. If you move from an area full of light-colored quartz and sandstone pebbles into a stretch with dark, heavy gravel, garnets, and black metallic grains, that's telling you something. Once you've identified a promising stretch of creek with indicator minerals, it's time to stop only looking and start processing material. The goal now is to let the differences in size and weight work in your favor, concentrating the heavy minerals into a much smaller volume so your eyes and your hands can actually keep up. That's where sieves come in. You don't need expensive or professional equipment to get started. A small set of sieves with different mesh sizes is more than enough. Think of it as a simple filter system. The coarsest sieve keeps out big rocks and debris, the middle one catches medium-sized pieces, and the finest one holds the small grains where most garnets, black sand, and tiny diamonds tend to hide. If all you have is a couple of stacked kitchen-style sieves with different mesh sizes, that already works as long as they're sturdy enough to handle gravel. The first step is to pick a specific working area instead of randomly scooping everywhere. Focus on inside bends where you see a bar of gravel, on the downstream side of big boulders and logs, and on spots where the creek narrows and the current was strong enough in past floods to drop heavy material. If there's exposed bedrock with pockets and cracks, that's even better. Scoop gravel from right on top of those features and from any dark, compacted layer just above the bedrock. With your coarse sieve in hand, load it with a reasonable amount of gravel, not so much that you can't move it. If the water is shallow and calm enough, you can submerge the sieve a little and start making gentle circular and side-to-side motions. The water will help wash away clay and silt. Lighter stones will move more easily, while the heavier ones settle toward the bottom. If you're stacking sieves, keep the finer one under the coarse one, so anything that falls through is caught instead of being lost back into the creek. After a short time, you'll see that the coarse sieve is left with only larger rocks. Take a quick look and remove anything obviously too big or too light. Some larger stones might still be interesting if they look unusually heavy or have metallic or glassy surfaces. But in general, your best material will be caught in the smaller meshes below. Move down to the next sieve, repeat the same washing and swirling motion, and then to the finest one. On the finest sieve, something important starts to happen. When you swirl and tilt it in a shallow pool of water, the lighter grains spread out, and the heaviest ones begin to form a band or a small concentration in one corner or along one side. That concentration is where the garnets, ilmenite, chromite, and any very dense clear grains will tend to sit. Spread that band out gently with your fingers or a small tool and examine it under good light. You're looking for tiny round red grains, garnet, very heavy black grains with metallic luster, and small transparent or slightly colored grains with a stronger shine than normal quartz. You won't find a diamond in every load of gravel, and you shouldn't expect that. At the beginning, consider it a win, just to see garnets and black sand piling up consistently. That means you're in the right environment and using the technique correctly. As you gain practice, your eyes will become much quicker at spotting anything that looks different. When you do find a small, clear, or pale stone that seems heavier than it should be, or has a strange metallic or oily luster, pick it out, rinse it carefully, and store it in a small vial or labeled bag. Don't worry about confirming it on the spot. All you need in the field is to separate interesting from clearly common. If your local creeks dry up during part of the year, that actually gives you an advantage. You can dig gravel from promising spots in the dry bed, bring it home in buckets, and run it through your sieves in a tub of water in your backyard or garage. The physics is exactly the same. You're using water, motion, and gravity to separate heavy minerals from the rest. Working at home also allows you to take breaks, use better lighting, and spend more time examining the concentrates without rushing. The important thing is consistency. The more buckets you process from the right type of gravel, the better your chances of eventually pulling out that first tiny diamond. Now let's jump to the moment everyone dreams about. You've done your homework, chosen a good creek, found garnets and heavy black sand, worked carefully with your sieves, and after several attempts, separated a few small stones that look different from the rest. Maybe they're colorless or slightly yellow. Maybe they look a bit greasy on the surface, and they feel heavier than their size suggests. How do you know if you've really found a diamond or just another piece of quartz or glass? The first thing to pay attention to is luster, the way the surface reflects light. A rough diamond doesn't sparkle like a cut stone in a ring, but it still has a very intense, sharp shine called adamantine luster. To the naked eye, that often looks like a mix of metal and very bright glass. Sometimes, especially in creek-worn stones, the surface can look slightly oily or waxy at the same time. Common quartz, on the other hand, has a more ordinary glassy luster, similar to a piece of broken bottle or window glass. If you place a suspected diamond next to a quartz pebble and move them both under a light, the diamond's reflections usually look crisper and more concentrated. Shape is also a clue, though not a rule. Diamonds that come straight out of hard rock deposits can preserve more of their original crystal form with recognizable faces and edges. Diamonds that have spent a long time in rivers and creeks tend to be more rounded, almost like tiny polished pebbles. They might still show traces of crystal faces, but smoothed by wear. So don't expect a perfect geometric crystal in a creek. Expect something small, dense, and slightly rounded with an unusual shine. Next comes hardness. Diamond is the hardest natural mineral, sitting at 10 on the Mohs scale. That means it can scratch any other common mineral, but virtually nothing will scratch it. You can take advantage of this with simple tools, as long as you're careful. One classic test is to gently try to scratch a piece of ordinary glass, like from an old jar or a picture frame. Clean both surfaces, press one edge of your suspect stone against the glass, and drag it firmly in a straight line. If nothing happens, the stone is probably too soft. If it leaves a clear, sharp scratch, that means the stone is at least as hard as quartz or harder. Quartz can also scratch glass, so this doesn't prove it's a diamond, but it does tell you that you're not dealing with something soft. To go a bit further, you can test whether the stone itself is easily scratched. A steel file or a very coarse sandpaper can be used very carefully on a tiny corner of the stone. If that corner gets visibly abraded or frosted with light pressure, the stone likely isn't diamond. Diamond resists scratching so well that, in practice, no common household tool should mark it easily. Be gentle and always test on a small area you don't mind damaging in case it turns out not to be valuable. Density is another powerful check. Diamonds are heavier than many common minerals of the same size. Quartz has a density of about 2.6, while diamond sits around 3.5. You can feel the difference with experience just by tossing similar-sized stones lightly in your hand. But there is a simple home experiment you can do if you have a digital kitchen or jewelry scale. First, weigh the stone in air and write down the weight. Then, fill a glass with water, tie the stone to a thin thread, or place it in a small, very light container, and submerge it completely in the water without letting it touch the bottom. Weigh it again while it's underwater. The difference between the two readings gives you an idea of how much water was displaced, which is related to the stone's volume. If you divide the weight in air by that difference, you get an approximate density. If the result is close to 2.6, it's more likely to be quartz. If it's closer to 3.4 or 3.5, it's behaving more like a diamond. At that point, the smartest move is to take it to a professional gemologist or an experienced jeweler who can confirm the identity with more advanced tools, even if it turns out not to be a diamond. By now, you already understand how diamonds can end up in creeks, how to read the behavior of water and gravel, which indicator minerals to look for, how to use sieves to concentrate heavy material, and how to run basic hardness and density tests. So it's time to talk about the big question that everyone has sooner or later. If you really find a rough diamond in a creek, how much can that stone actually be worth? The first thing you need to know is that diamond pricing is complex. The value of a diamond, even in rough form, depends on several factors at the same time: weight in carats, color, clarity, shape, and how much of the rough stone can be turned into polished gems. There's no universal fixed price per carat for a rough diamond. Instead, there are ranges, and those ranges change over time as the market moves. On the low end, you have rough diamonds that are only good for industrial use. These are stones that are too included, too fractured, too cloudy, or too dark to be worth cutting into jewelry. Industry uses them for cutting, drilling, and grinding tools. Many of these lower-grade stones are sold in parcels, where the price per carat can be relatively low, especially compared to high-end gem material. As quality improves, so does the price. Commercial rough diamonds with reasonable color and clarity that can produce decent polished stones can sell for much more. In this range, a stone's value might move from tens of dollars per carat into the hundreds of dollars per carat, depending on size and overall appearance. When you look at individual rough diamonds sold for gem purposes, especially in the 1 to 3 carat range, the numbers can rise quickly. A clean, well-shaped rough diamond of 1 or 2 carats can sometimes reach several $100s per carat or more, again depending on how it is expected to cut and what the resulting polished stones will be worth. For particularly attractive rough, the price can go into the low thousands of dollars per carat. What does all that mean for a creek diamond? Realistically, most of the first diamonds that hobby prospectors find in creeks are small, often under 1 carat, and may have noticeable inclusions or color issues. Many of them would fall closer to the lower or mid part of the price spectrum, especially if sold to a dealer who has to cover cutting losses, certification, operating costs, and profit. It's completely possible for a tiny included stone to be worth something like tens of dollars, not thousands, even though it's still a real diamond. But there is also the other side. If you happen to find a rough diamond in the 1 to 3 carat range with good clarity, decent color, in a shape that cutters like, the potential value rises quickly. A stone like that might be placed in a category where hundreds of dollars per carat or more are realistic, and in some cases it can reach into the low thousands per carat, depending on how it will cut and what the polished gems are expected to be worth. That means a single good crystal could represent enough money to cover your equipment, several prospecting trips, and still leave a solid profit. Above that, for larger and cleaner stones, prices can become very impressive. High-end rough used to create luxury jewelry, especially in larger sizes with excellent color and clarity, can sell for several $1,000s per carat. Unique top-quality stones can go way beyond that when they reach auctions. But those are exceptions that almost never come from casual creek prospecting. Still, it's important to understand that the range exists so you don't dismiss a good stone just because it came out of shallow water. The key is to stay balanced. Don't go into a creek expecting to pull out a life-changing stone on your first day, but also don't underestimate what you find. A small, imperfect diamond may have modest monetary value, but huge practical value, because it proves that your creek is truly diamond-bearing. From that moment on, every bucket of gravel you process isn't just a guess, it's a calculated effort in a confirmed area. But before you rush out to start searching for rocks that could be worth a fortune, there's one last thing you need to remember. Even if the stone you find isn't a diamond, that doesn't mean it has no value. A lot of people pick up an unusual rock in a creek, assume it's just another pebble, and either throw it away or give it away for almost nothing, when it could actually be a garnet, a sapphire, a piece of jade, or another gemstone. That's exactly why I created the book Gemology Journey for Beginners, available on Amazon. It's a straightforward, practical guide for anyone who wants to learn how to identify the most common types of gems and minerals, even without professional tools. Inside, you'll learn simple hardness, density, texture, and luster tests using everyday objects, so you can understand what you really brought home instead of guessing. With this knowledge, you won't have to rely on luck or someone else's opinion. You'll be able to decide what to keep, what to sell, and what to add to your collection with much more confidence. Now, if you're still taking your first steps or just not ready to grab the book yet, that's perfectly fine. You can still subscribe for free right now, and watch the next video appearing on your screen, where you can learn more about gem hunting secret techniques. Thanks for liking and subscribing. Good luck, gem hunter!